Alright, so this is a video for Math 125. Whoop. Let me see if I can change the color there real quick. Uh, this is, we're just working through day one issues here. And so the biggest thing that we talked about, we talked about the syllabus and we talked about what is calculus in general. But in these notes, I really want to focus on the meat of what we were talking about, and that is in defining and working with functions. Okay, so that's really the whole point of section 1.1 is to define and work with functions. So, quick definition: a function is a rule uh, that associates one number let me pause this so you don't have to watch me do that. Okay, so a function is a rule that associates one number in the domain to exactly one number in the range. Okay, so each number in the domain gets sent to a unique number in the, well, I shouldn't say that. Every point, if this is a set of points representing our domain, and this is a set of points corresponding to our range, then we're thinking of the function as changing all of these points in the domain to these points in the range. Okay, so all of these points are getting transformed to these points. Okay, so the idea behind a function is that you need to know the output with certainty. You can't have any uncertainty in your output. And so therefore each output has to be unique. It has to be, you only have one possible output for each input. Okay, so that means, you could send, if you're looking at a table of values, x's and y's for your function, that means that you could send like the point 2 to the value 5, and the point 3 to the value 5, and the point -1 to the value 5. This is okay because each x is only going to a single y. Okay, what's not allowed is the opposite, where the point 5, for example, gets sent to either 2 or 3 or -1. So this is not a function. Okay, but this is a function. Okay, so this is what we need to rule out. Okay, so algebraically it's pretty easy to see. So for example, if I just have, f of x equals 2x squared plus 3x plus 1, that's an algebraic way of defining a function. And so our inputs are denoted by the x here. So the x here is our domain value. And so this is telling us how to compute the output. And so you can see, for any value of x that you put into this expression, only one possible y will come out. Okay, so let's take a look at several ways. You can kind of see here that I've been using several ways of looking at or thinking about a function. So let's be a little bit more formal about that. So there are 4 ways to define a function. The first one is a verbal description. We talked about that in class. So what I mean by that is, for example, you could say, let my function temp be the temperature of the chicken that's sitting in my stove and warming up. Okay, so that would be an example of a function, right? Because at each time t, right, the temperature of the chicken should be a unique value. Okay, and that's a verbal description of your function. But of course that's hard to analyze. Rather, it's probably easier to have an algebraic definition for a function. So for example, that was the if you have y equals f of x, the x here is your domain value, your y is your range value, or it's the label for the range, and the f here is the name of the function. Okay, so therefore if I say like g of x is equal to, let's change the notation a little bit. How about g of t is equal to the square root of 3 plus t minus the square root of 2 minus t. Right, let me see if I can write that a little better. Okay, 3 plus t. There we go. So this is not saying this is g times t. Oops, somebody's at my door. Just a sec. Okay, so yeah, this is not g times t on the left-hand side over here. However, we might ask a question about this expression. We could ask, what is the domain? And so if it's not expressed, or if it's not defined, the domain is the set of all numbers that make G defined. You could say defined or computable. You know, you could, or G of x is computable, or G of t is computable. It depends on your notation. Okay, so for example, in this example up here, can we compute something like G of 5? Well, that would be the square root of 3 plus 5. That's okay. Minus the square root of 2 minus 5. We're going to run into trouble, right? Because that's the square root of minus 3, and that's not allowed. Okay, so this says that 5 is not in the domain. 5 is not in the domain. Okay, so how do we find the domain then? Well, in our case here, let me rewrite our function. G of t was the square root of 3 plus t. 3 plus t minus square root of 2 minus t. We require that both of these expressions are positive, so 3 plus t is greater than, they could be 0 as well. And we need that 2 minus t is less than, greater than or equal to 0. Good. All right, and so just solving these, I'm just going to subtract 3 from both sides here. So t must be bigger than or equal to minus 3. And over here, I'm going to add t to both sides, because you have to be careful about multiplying by -1. You don't want to do that if you don't have to. So 2 is greater than or equal to t. Okay? And so if you're not sure how to solve that, you can look at that on a number line. Minus 3, 0, 2. So this first expression, my first expression says that t is bigger than or equal to minus 3. And then the second expression says that t is less than or equal to minus 2. And so altogether then, we see that our domain is going to be this interval that satisfies both of those. So that says that t is bigger than or equal to minus 3, less than or equal to 2. Good. All right, and so there are other things that we might have to do to find the domain. Hitting the wrong buttons. Okay, this video is up to 10 minutes, so I'm going to stop here and we'll put another video up. I don't like to make videos that are longer than about 10 minutes long, so we'll pick this up where we left off in the next video.